Meet the J10C, China's main character energy fighter jet. Let's decode its visual DNA. First up, this gray nose cone. No more old-school black. It hides a massive AESA radar. See this tiny glass ball? That's the IRST sensor. It tracks targets using pure heat. Stealthy. Right here is the retractable refueling probe. Keeps us fueled up without ruining the jet's aerodynamics. The single-piece bubble canopy. Maximum visibility, 0 blind spots. Perfect for keeping eyes on the prize. These mini-wings are canards. They glitch physics to give this jet insane, mind-bending agility in dogfights. The ultimate J10C flex. The DSI intake. No heavy splitter plates, just pure, seamless airflow geometry. Massive delta wings. This shape means low drag at supersonic speeds. It's built for pure speed. These pylons carry PL10 and PL15 missiles. Basically, fire and forget delete buttons for anything in the sky. The vertical tail fin is massive. It keeps this absolute beast stable when pulling heavy G-turns. Spot the 3-blade antennas on the spine? That's the J10C giveaway. Upgraded net-centric electronic warfare suite. Sleek, smart, and lethal. That's the J10C aesthetic. Hit follow for more aero breakdowns. You've seen the J10C, now meet its favorite delete button, the PL15. This isn't just a missile, it's a literal sky boss. Let's decode it. First flex? Speed. It packs a dual-pulse solid rocket motor that pushes it past Mach 4. That is literally 4 times the speed of sound. To fire this beast, the J10C's mission computer runs a full system handshake. Fire control locks the target cords, and it launches cold or hot. Trigger pulled. The umbilical disconnects, the missile drops away, and the primary rocket pulse kicks in with absolute violence. Instead of flying straight, it lofts. It climbs sharply into the upper atmosphere, using its energy to maximize a massive 200-kilometer range. And right here is the peak. It hits its maximum ceiling at nearly 25,000 meters. The air up here is practically non-existent, eliminating drag entirely. While cruising, it's not alone. It features an active 2-way data link. My J10C continuously feeds it live, mid-course coordinate updates. Plot twist, I don't even have to keep my radar on. A friendly AWACS aircraft can guide this missile via data link instead. Pure teamwork. AESA radar technical details are as shown. Write them down. Don't bother trying to dodge. Those tail fins twitch instantly to pull insane airframe snapping maneuvers up to 30 G. It doesn't even need to physically touch the target. These optical laser proximity fuses sense when a target is near and trigger detonation. Sleek, networked, and absolutely lethal. That's the PL15 meta. Drop a comment on what hardware we analyze next.
The J10C is a beast, but its real cheat code? The PL15 air-to-air missile. Today, we're talking about how to survive it. This thing has an insane kinematic reach. Why? Because it packs a dual-pulse solid rocket motor that changes the entire BVR meta. This thing has an in-J10 kinematic reach. Why? When that J10-seater initiates a fire control handshake, the P-exact coordinates before it even drops.
Rule number 1 for survival is initial standoff distance. If you are far enough away at launch, you've already won half the battle. Every active radar missile has a weakness built into its brain. The pulse Doppler radar filter. We are going to exploit it. We start the 90-degree notch maneuver. We are turning hard to put that missile completely perpendicular to our fuselage. Lock it exactly at your 3 o'clock or 9 o'clock position. You need to maintain a strict 90-degree angle relative to its path. By flying completely perpendicular, your closure rate relative to the missile's radar seeker drops down near absolute zero. The missile's onboard computer stationary objects. By matching the ground speed profile, you become ground clutter. Positioning alone isn't always enough. As you hit that 90-degree notch threshold, we start micro-chaffing. Drop successive chaff bundles. This creates a dense, radar-reflective cloud. This is right in the blind spot of the PL15. Combine the chaff drops with gentle, snake-like weave turns. Do not fly a straight line through your notch.
The missile's radar tracking gates get confused by the combination, dropping your airframe and locking onto the chaff decoy.
Next up, cranking. DCS guides highlight this as the ultimate way to defeat a PL15 long before it goes active. Step 1. Fire your own weapon first to force the adversary jet onto the defensive. Get your missile in the air. The moment your weapon clears, turn your nose away to the absolute edge of your radar's physical limit. Then edge of your radar's physical gimbal limit. Hold it right at 50 to 60 degrees to the side. You are maintaining your own radar tracking loop while maximizing offset. This maneuver forces the incoming PL15 to fly an incredibly inefficient, wide curved intercept path instead of a straight line. Because it is constantly turning to chase your angled profile, it burns through its dual-pole pulse rocket motor fuel way too fast. If the PL15 is fired from max distance, we use the atmosphere itself as our ultimate defensive shield. Roll the aircraft completely over and execute a continuous, steep diving turn straight down to the deck. This forces the high-altitude missile to leave the thin stratosphere and follow you down into heavy air. Missiles have tiny control fins compared to the massive lifting wings of a modern 4.5 generation fighter jet. Thick air creates intense, aerodynamic drag on a fast projectile, turning its own speed against it. Constantly turning in heavy, dense air rapidly bleeds the missile's remaining kinetic energy, killing its speed entirely. But what if you are caught inside the no-escape zone? The RWR is screaming terminal active threat. Time for last-ditch measures. Slam the throttle into full afterburner instantly. You need every knot of airspeed you can muster right now. Wait until the missile is close. Timing is everything. Do not panic, pull early. Wait for the terminal threshold. Pull! Execute a maximum G snap turn directly across or into the incoming missile's flight path trajectory. This forces the missile to match an impossible angular rate change. Its tracking logic overcorrects, snapping its energy profile entirely. Backed up by advanced internal DRFM jammers, the PL15 stands zero chance of reacquiring your airframe skin once the lock breaks. That is the BVR meta breakdown. Massive credit to the DCS YouTube channel community for the flight tactics. Hit follow for more aero intel. Fighter jets have it easy. But how does a massive maritime patrol plane or a thick refueling tanker survive a Mach 4 PL-15 missile? Let's decode the heavy defense meta. Spoiler alert, we aren't pulling 9G snap turns or doing wild cinematic barrel rolls in an airliner frame. Our defense is pure brains and network electronic warfare. The PL-15 has a massive beyond visual range reach, exceeding 200 kilometers. Surviving it means breaking the kill chain early. Defense step 1 is outranging the launch platform. The moment an advanced fighter approaches the weapon baseline, we react. We immediately turn 180 degrees away. Forcing a missile to chase a heavy asset that is already moving away drastically reduces its real-world reach. If they manage to get a launch off, we unleash our biggest advantage, an absolute mountain of onboard electrical generator power for jamming. The missile requires data updates from the fighter jet while cruising. Our high-power jammers target that wireless's connection to break the tracking loop. Using advanced DRFM jamming, we flood the skies with noise and fake target signatures, disrupting the mid-course updates sent to the missile. Eventually, the PL15 goes active, turning on its own internal AESA radar seeker to hunt us down solo. We don't panic. Our directional EW suite zeroes in on the missile's specific seeker frequency, attempting to blind its calculation gates completely. Now we use physics as we did before. We execute a maximum rate emergency descent, down into the thick, dense lower atmosphere.
By diving to the deck, we force the high-speed PL15 to follow us in thick air, which acts as rapidly starves it. Without more rocket propellant, the heavy drag defeats PL15 kinetically.
But if it gets close, we deploy heavy countermeasures. Fighter jets drop tiny individual bundles, we release absolute oceans of chaff. This massive, highly reflective cloud creates a giant radar signature that swallows the missile's active tracking logic entirely. Our ultimate insurance policy? The towed radar decoy. We deploy an active transmitter on a long cable right behind our tail. The decoy actively emits an amplified electronic signature. This makes it look like the main, giant airframe to the incoming threat. The PL-15's AESA seeker locks onto the trailing transmitter decoy instead of our real fuselage skin, pulling its tracking gates away. The missile passes us cleanly by hundreds of feet, tracking towards the tether point, safely out of structural harm's way. For the bulky aircraft, we have one final low-altitude trick: terrain masking. We drop right down to the surface profile. By flying low parallel to the sea waves, we blend directly into the immense surface return clutter, breaking the pulse Doppler filter lock completely. Brains over brawn, every single time. That is the heavy asset defense breakdown. Drop a comment on what flight matrix we analyze next.